Hello again. We've been working with the sine graph. We worked with the amplitude, which meant we took a number and we multiplied it in front of the sine graph. If it was a bigger number than 1, the graph, went like that. If it was a number smaller than 1, the graph kind of compressed. Well, not compressed, I guess, is this way. It's like somebody squished it. If we added a number after the quantity, not in the quantity, we did something called a vertical shift. We took the graph and we kind of moved it up or down. If it was positive, it moved up. If it was negative, it moved down. We did a phase shift, which meant that if we added or subtracted a number after the theta measure, or after our x or angle measure, whatever you want to call it, we shifted it to the left or to the right. If it was theta plus pi, we actually shifted it to the left pi units. If it was theta minus pi, we did a phase shift to the right pi units. Now what we're going to do is we're going to affect the period of the graph. And I did this when I did my guitar thing. If you put in a higher note, and this is actually what I mean by a higher note, a number in front of the theta, it affects the period of the graph. Really cool. And I went ahead and I did my basic sine graph again. Notice that it is continuous, it keeps going, it doesn't stop, but I just wanted to go from 0 to 2 pi, but it goes on forever this way, and it goes on forever this way. The domain is from negative infinity to positive infinity, the range is from negative 1 to 1. Well, what's going to happen when I do this? 2 times theta, how does that affect the graph? See, people say, oh, it gets higher. No, that's amplitude. It moves up or down. No, that's vertical shift. It moves from side to side. No, that's phase shift. What does this do? It's pretty much the last form of manipulation on a sine graph in its own right. I mean, you could put them all in and you will never really know what's going on, but if you do one individually each time, then you'll see how each one works. So here we go. Let's figure it out. The sine of 0 is 0. Well, let me phrase it this way. 2 times 0 degrees is 0 degrees. Sine of 0 degrees is 0. Sine of pi over 4 is 45. 2 times 45 is 90. So that's how I do it. Even though I put it in radians, I always convert it to degrees. Sine of 90 degrees is 1. But it's not root 2 over 2, because 2 times 45 degrees is 90 degrees, it's 1. This is 90 degrees. Sine of 90 degrees is, well, let me phrase it this way. This is 90 degrees. 2 times 90 degrees is 180. Sine of 180 is 0. This is 3 pi over 4, which is 100 and, gosh, I can't believe I have to sit here and do this. 135 degrees. 2 times 135 degrees is 270 degrees. Sine of 270 degrees is negative 1. This is 180 degrees. 2 times 100, see, now it's flowing easily. 2 times 180 degrees is 360 degrees. Sine of 360 degrees is 0. 5 pi over 4 is 225 degrees, which 2 times 225 degrees is 450 degrees. Sine of 450 degrees is 1. I actually already know the value, I'm just trying to do the computation. You can probably guess what this one's going to be. 3 pi over 2 is 270 degrees. 2 times 270 degrees is 540 degrees. The sine of 540 degrees is 360 plus another 180, which is 0. Anybody guess what that one is? 7 pi over 4 is 315 degrees. 2 times 315 degrees is 630 degrees. Sine of 630 degrees is 360 plus another, 270 degrees. Sine of 270 degrees, I know, is negative 1. This one's easy. This is 360 degrees. 2 times 360 degrees is 720 degrees. Sine of 720 degrees is basically the sine of 360 degrees, which is 0. After this point, you could have probably started to figure it out, because it's periodic. The graph will, keep kind of repeating the values that it's supposed to. This is not going to be a nice graph in terms of drawing, because I won't, elaborate on my points well, but it is what it is. Each dash is pi over 4. So 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. But the graph doesn't go like this. It's not straight lines. It's a curved graph. It's a nice curved graph. And basically what happens is it looks something like this. Where is it? Lost my spot. There you go. What does that do? Well, I'm glad that you asked. When I did my guitar analogy, basically I said it's like the same note, except it's a higher note. You know, this is an E, this is a higher E. It causes the same graph, except what happens is that its period is shortened. Notice here that it basically looks like you took the red graph and kind of squished it in. Well, that's what you basically did. So instead of repeating, or instead of the period being at 360 degrees, you know, this red one goes here and then finally repeats at 360. This one repeats here, halfway. It's basically half the period. Basically what you do is the graph goes faster. If you put in a higher number, the graph goes like this. If you put in a lower number, like 1/4, then the graph expands. So that's basically what it does. It shortens the period of a graph. In this particular case, if you put in a lower number, it lengthens the period. Now some people are going to ask, well, how can you determine that? Well, I'm glad you asked. Here's how you can basically do it. If you want to find the period of any sine or cosine graph, all you have to do is take 2 pi, over the number being multiplied in front of the theta. Not in front of the sine, not added or subtracted after the theta, and certainly not added or subtracted after the quantity. The number in front of the theta in this case is 1. So if you want to find the period, take 2 pi over that number. 2 pi over 1 is 2 pi. The period of the first graph, of the red graph, is 2 pi. You know, somebody says it repeats here. Well, no, I already talked about that. It has to hit the same spot, but it has to be going in the same direction too. So this one goes up here, this one goes down, this one goes up, and they both hit 0. That's where the period is. That's where it starts to repeat. In this case, it's 2 pi over the number in front of the theta. Well, now the number in front of the theta is 2, so the period for the second graph is pi. Pi radians, or 180 degrees, that's where it repeats. Pretty cool, like I said before. So I think I'm going to try to put all this together and see how it goes, just on the fly. Cool though. A basic introduction. I'm not going to be doing phase shift, vertical shift, period for the cosine, because if you know how the aspect works with the sine, all you got to do is just imply it properly with the cosine. But with that said, have a good day for now. Goodbye.